about Zoom. Thanks, Keith, and thanks, Ashley. I appreciate the introduction. I appreciate being invited, the people that showed up here in the room, people online. Great opportunity. Love to come and talk to people about LiDAR. Keith named it Unlocking LiDAR. I like the name for this tech talk. So we're going to talk about LiDAR in general today. I promise you I will not give any sort of sales pitch whatsoever, because I hate it when people do that when they give these things, but I'm going to tell you at least where I'm from. So I work for a company called MD5 in the geospatial division. MD5 is a big engineering company. Our division is about 1,400 people that do kind of soup to nuts, A to Z acquisition. We have a fleet of aircraft. We have 40 different sensors. We have boats. We have cars. We have helicopters, UAS, all that stuff. So going out and flying LiDAR, imagery data, a bunch of data processing people that turn it into mapping products, things using GIS, all sorts of derivative things. And then we really like analytics, like answering questions, specific questions from people that come to us and say, hey, we're trying to solve this problem. How can remote sensing help us do that? So that's who I work for. It's my 26th year doing remote sensing. When we get to questions and answers, I'll warn you right now, I've been doing it a while. I know something about something, but things are moving really fast. And so I run out of answers on some of these topics pretty quick. And if you have something specific I can't answer, I can certainly get you to somebody that can answer it. So I do not have a PhD in LiDAR. Presentation goals. So I do similar kinds of talks, people sometimes about LiDAR and sort of how to maximize its value. Keith wanted to talk some about high density LiDAR, which we will do. But these are like, I do like rapid fire, right? I'm not doing a point classification demo. I'm not doing, in depth on any single topic, but more, banging a bunch of stuff at you to get your mind thinking about how you can use LiDAR, how you haven't thought about it before. You can make it personal and say, how does it help me be selfish? Things that would improve the quality of decision-making in my organization, all those sorts of things. And then a big personal thing for me is sort of maximizing the value. This stuff costs a bunch of money. Like a lot of it, what we're talking about today, people have already flown, you've already paid for it. Why not use it in multiple ways that can give value to a bunch of different people or organizations? So we'll chat about that. The reason why it's timely in my mind and why I do quite a few of these things is because we've gotten to the point where the whole country, basically 98%, is covered with some level of LiDAR, right? Maybe not what we would call high density LiDAR, but a LiDAR base specification from the USGS that has been going on now for 7, 8, 9 years, where we've been trying to cover the whole country. Based on which map I look at, some of those are from Idaho LiDAR Consortium, I think, projects in progress, things that are done. USGS claims you're all covered. I don't know. So we're all covered. So anyway, there's a bunch of LiDAR in Idaho already. The thing with high density LiDAR is that, technology has changed. There's an opportunity really to collect higher density to some degree, UAS, our fixed wing stuff. We'll talk about helicopters, all that. So that's kind of why we're here. And of course, because Keith asked me, which is very kind, and I managed to get here in person, which I'm really happy about. So I'm going to make the assumption, because I asked Keith what the audience would be, and he said it'd be kind of a mix of people that know LiDAR, don't know LiDAR. I'm not going to spend a lot of time explaining the technology, but generally speaking, all sorts of different kinds of sensors. The general idea is it's on some platform, right? A fixed wing aircraft, a rotary wing, a vehicle, a UAS. We have them on boats. But you've got a sensor, it's shooting out millions of laser points, usually from the air. It's going down. We know the position and the attitude of the aircraft. It hits an object, it comes back to the plane. We're collecting a 3D point in space that identifies something it hit on the ground, right? So we're creating these point clouds at various densities to identify things that are on the ground. What you end up with is, point clouds or millions and millions of points of 3D measurement across the earth. So all sorts of different kinds of sensors. These are some of the ones we own. There's other different kinds other people own. I put a few cameras on the other side of it because generally speaking, and you'll see when I'm talking today, there's imagery. We collect a lot of imagery with the LiDAR at the same time. It's sometimes better if you have both imagery and LiDAR. So that does happen. But general idea of LiDAR is collecting these massive sets of 3D points. So densities, this was a question I asked Keith. He said, let's talk about high density LiDAR. and my next question was, what does that mean to you? Because the LiDAR-based classification for USGS, QL2, that was sort of the standard for across the country, is 2 points per meter, not high density, but really good for 10-centimeter accuracy terrain, running contours, doing all sorts of analysis. QL1 and QL0 are 8 points per meter, which in my mind starts to get you to a higher density level. But then for other applications, some of which we'll talk about today, 20 points per meter. What does that mean? Every square meter on the ground, that's how many measurements you're getting, or in the air, if you're hitting trees or buildings, whatever. 50 points per meter, 100 points per meter, pretty rare, right? Maybe if you're doing UAS collection in really small sites. So there's all sorts of things that go into that. What's the scale of the project? How accurate does it need to be? What's the use case? Why do I need 100 points? Why do I need 50 points? What platform are you using? Big one is cost, right? It costs a lot of money to fly big areas with super high density LiDAR. So while it might work for a 2-acre site with the UAS, if you're doing 10 million acres, tough to get to that density. And then usability is another question. So if you have this big, massive project, but you can't use the point data because it's so darn big, then does it have any utility? So we'll kind of chit chat. Couple of examples. There's 2 point per meter, right? That's good to get ground and contours and things. There's 4. Starting to not even be able to tell what that is. At 10, starting to look like something. 20, it's trees, right? 40, you're starting to get sort of more structure. So to give you an idea of the definition of an object goes up as the point gets up. So for some things, yeah, it's better to have high density. So I want to start with, I'm just getting over a cold, so excuse me, that's water. With what we have and maximizing it. So USGS, as I said, has done a lot of work. It's done work here in Idaho and all over the country, filling out our landscape with LiDAR. There's a standard set of deliverables. When we collect LiDAR, we classify all those measurements into something, right? For USGS, we're really concerned about the ground. So what does the ground look like? So it's sort of ground, bridges, water, everything else. That's the way we classify it, right? 3 main classes that we care about. And the reason why that is because you're trying to get to 2 real deliverables. The point cloud, right? This is point cloud, strip everything away, and we've got the, for those of you online, I'm pointing at the screen, the bare earth and the DEM, or digital elevation model of surface. Those are the main deliverables for USGS. That's what we're trying to get to. Great stuff. Tons of use cases. So when we think about USGS LiDAR, we think about DEMs, floodplain management, preliminary engineering, all sorts of natural resource stuff that we can use those main deliverables, the point cloud, the DEM, to sort of get to these use cases. I've listed a bunch of stuff here. I'm not going to read them all off, but some of those use cases are, you can use the lower point densities. It's better if you have higher density. So we'll talk about sort of how to look at density and what it means for these use cases. I did want to say there's a bunch of derivatives that you can create from the existing USGS LiDAR, which is free. I mean, free in the sense it's publicly available. Somebody paid for it. We all paid for a lot of it. But other raster derivatives, super cheap, easy to do. If you know what you're doing with, Esri or whatever GIS you're using, a lot of these you can generate in those environments. Slope, aspect, geomorph classification, digital surface models, which is the first hit of the LiDAR across the landscape. All these sort of base raster deliverables that feed into answering questions like I was talking about before, particularly within the natural resource realm, but also hazards, has something to do with our forestry mapping, has things to do with the utility mapping that we'll talk about in a little bit. But these things are easy to generate. They have more value by adding these sort of cheap, easy deliverables from the existing LiDAR. So this, in my mind, is you start to maximize the value of the things that are already there before you go out and do something new. Additional classifications. So I said we only do 3 classes, and a lot of the things that I'll talk about today require additional classification. And you can continue to classify these LiDAR point clouds beyond what's available. So buildings, vegetation, roads. We'll talk about when we talk about utilities, everything depending on the density. You're not going to hear me talk a ton about AI today. I know you wish I would because it's all anybody talks about. But I will say from a classification and process standpoint for LiDAR, it's having a big impact, right? We've always used macros and sort of automated stuff, but machine learning, deep learning, now we're taking huge data sets and being able to get to, buildings, fences, rooftop units, roads, all these things, like utility poles, on and on and on, depending on the density in an automated fashion. Are they perfect? No. But we're getting to 95%, 98% classification of these point clouds without manual intervention. And so manual intervention is time and cost. And so AI right now, from a LiDAR classification standpoint, is really helping sort of being able to let us generate these detailed point clouds, but faster and more cost effectively for people that we work with. So anyway, that's sort of a foundation maybe for some of these other use cases. Don't forget about, the mapping, vector mapping that we use in GIS. So different features that you can extract, buildings, planimetric mapping, compare it with imagery, get other data sets, run contours, all those things that maybe you care about when you're doing engineering design, GIS mapping, city planning, all that sort of stuff. All right. Onward. Hydrography derivatives. I'll talk quickly about this. It's related to the 3-depth program of the LiDAR mapping program for USGS. The new big push, because the country's covered in LiDAR, is to say, hey, can we update all the hydrography across the entire United States? So there's something called the National Hydrography data set. It was originally manually digitized off of 10-meter DEMs, I believe, not particularly accurate, good data set, but not as accurate as you can do deriving it from this new LiDAR. So funding, there's USGS is starting to partner like they did on 3-depth. So if you have some money, you're interested in updating hydrography data sets, which have big impact on flood modeling, a bunch of other hydro-related modeling. This LiDAR now is being used to get that to within, plus or minus 10 centimeters vertically and maybe a meter horizontally. So really cool stuff for those of you that use that kind of data set. It's a lot of companies, ours included, spent a ton of time trying to automate this process because, as you can imagine, it's a heavy lift to try to update every single hydro line in the country. But as I said, USGS has just started helping people fund this, and it's a cool thing. Also defining watershed boundaries, updating that data as you go. That's also happening. Really cool stuff happening with integration. If you work at a municipality or an agency, water agency, all this stuff can be integrated with underground flow, right? So if you get to a city, you basically have a hydrographic desert. You don't really know where the water goes because there is no terrain to sort of define where it's flowing. Sure, you might have canals or streams or whatever, but most of the water, when it rains, goes underground and you know where it goes. So you can connect your terrain hydrography, understand where the water goes underneath your city, where it comes back out. We're essentially creating sewer sheds, like watersheds, so we can pair every single inlet with an outlet. And it's really great at trying to manage sort of flow. So anyway, again, all this stuff from existing LiDAR. Now we will move on to new topics. So I talked to Keith briefly about green laser LiDAR. I would not be talking about this if you were in Alabama right now, because it doesn't work so good in places like that. But green laser LiDAR is LiDAR that measures underwater. Okay, so generally with a red laser, our laser that we use for topo hits water. That's it, no return. It just gets stuck into the water. But green laser will penetrate the water, go down to the bottom, back up, and we'll get water surface. So cool technology. Most of the sensors have both red and green lasers on them, so you're getting terrain just like you would normally, but you're also getting underwater measurements. So this is happening a lot near shore in the ocean. There's some systems like the Hawkeye, the third one down, that's a deep water channel. So if you're doing super deep stuff in the ocean, you mapping that for storm hardening and emergency response for hurricanes, all that stuff. But in places like Idaho, we're doing it a bunch for inland waterways, right? Riverine environments, for engineering, for infrastructure planning. So really cool sensors. I put this one in here because we're going to get it pretty soon, but that's a helicopter based sensor. So we can do really, you have to fly these sensors low, so the lasers aren't real powerful. So helicopters are safer than trying to fly a fixed wing along a valley floor or a marine environment. So it's got a bunch of these. Yes, sir.
Green LiDAR can penetrate water.
Yes.
Why can't you use green LiDAR on the campus?
You can. You'll get a return. Yeah. So the reason why they put two sensors on those systems is because the green lasers are so much less powerful. We fly super low, and so the swath width is not very good, like in terms of coverage. So from a cost perspective, if you went out and did a ton of terrain with only the green laser, the cost goes through the roof. So if you have both, you can fly and get green laser. Red laser, you could fly higher and get terrain as well. So it's kind of a cost situation, and wanting to be able to get overbank if you're doing riverines, shoreline if you're doing standing water. So it's the technology I talk the most people out of. So I said it probably wouldn't work in Alabama so good. It likes clear water. It likes hard bottoms, like reflective bottoms. It does not like mush. It doesn't like a ton of turbidity. Doesn't like highly aerated waters. But freestone rivers, awesome, right? Gin clear water for fly fish. Everybody likes to go out and see a perfect river. Those are the kind of places that works great. Really clear lakes, awesome. If your water looks like this and you call me, I will talk you out of it in 5 minutes because it won't work. It just won't get it data. When it does work though, super cool. So this is a lake example. That happens to be Tahoe, but that's the bottom of the lake, right? So I think in this case we were looking for some kind of, it was a habitat thing, I believe. The other one, another typical sort of application is a river environment. So instead of having a flat river like you'd see in a DEM that's generated from topo LiDAR, where we just sort of flatten the water and put brake lines around it, now you have a complete DEM of the water and the terrain around it. So super cool technology. It's gotten way more popular in the last 10 years. Those sensors are way better, the processing is way better. There's a bunch of other stuff you have to deal with because of the water refraction and things, but really neat technology. Oh man, time. 10? Oh, I'm gonna go faster. No more topopathy. But anyway, lots of use cases. We'll go on to vegetation analytics, because this sort of feeds into a bunch of other stuff we'll talk about. But this is where we get into higher density is really better. And to start with, we're always sort of shooting for this idea of being able to identify individual trees. So I'll talk about a little bit about how we do that. You can see over here, we like to be up in the, you can do it with 8 points per meter. You can even do it with 2 if you want to, but it reduces accuracy and specificity and all sorts of things. So we like to get beyond 20 points per meter. The more, the better. You can see over there how much definition you get when you get up into high definition LiDAR. What we're trying to do is we're trying to individually identify trees within the LiDAR point cloud. So there's a bunch of ways to do that. We don't have time to talk about it today, but sort of this general geometric system is good for simple forests, where you're looking at the nearest tree next to it and saying, okay, based on structure and what I know about height and canopy, this is a tree, right? And we're trying to get to individual tree segmentation. If you look up to the left or to the, looking this way to the right, those are all individual trees, right, that we've identified as within the canopy. Then you can assign a stem location to it, so you get tree counts. You have a 3D model, so you can get volumetrics. If you're a timber company, you can get board feet, those kind of things. So all sorts of applications in the forestry, timber, urban forestry management industry. For species and tree health, we won't make this whole video go, but if we look here, once you have those individual trees, you can start adding imagery like hyperspectral or 4-band imagery. You can start to identify species. Okay, so what are the species of the trees? What are the health of the trees? And if you are looking for, potential problems, oak wilt, pine beetle, ash borer, all those things, you can identify the specific tree type, what their tree health is. Maybe there's mitigation involved with it. But it's a powerful tool for a lot of reasons. Fire risk is a huge one, right? When we're doing forestry work, individual trees, and volume and canopy enclosure and all those things sort of feed into fire risk models. Understory, what's on the ground, will it light on fire, how fast will it burn? Very important when we're talking about utilities, it can be our next topic. I don't know how many of you are aware, but within the electric utility world, there's about $1 gazillion spent on trimming trees every year so that the power doesn't go out, so things don't light on fire. And it's been used in the power industry, LiDAR, for many years, 15 plus years, for modeling T-lines, doing things like when it's loaded, how far does a T-line blow out? What would it run into? How far does it sag when it's hot outside and you're running a bunch of power through it? So we've been doing that kind of stuff for a long time. Really specific sensors that have been built for this kind of mapping. What's more interesting to me is the vegetation management risk analysis. So you have to worry about when you have T-lines and distribution lines, trees falling in, right? Smash, knock out power, light fire. Trees growing into lines. If you see in your neighborhood, people are out and they're cutting along the distribution lines, you go, geez, they just hacked off 8 feet of that tree. Yes, they did, because they don't want it going into the line. All that stuff used to get done manually. So boots on the ground, right? You go out and you take a look, see how much needs to be trimmed. You pay somebody, Davy Tree, whoever, Ashland. Now all this stuff, a lot of this stuff is getting done with LiDAR. So you're looking at these different exposures to the lines and how they relate to vegetation. When you do real high density mapping, it allows you to do some cool stuff. Oh no, what did I do? Speed it along a little bit. So then you're identifying specific threats, like how close is it to the line? Is it going to fall in? We know that this tree is 1.5 feet away, or 3 feet away, or 6 feet away. Those all have different risk factors. Like it will determine whether things can fall in. It starts to give you an idea of where do we go out and start cutting vegetation to maintain the system. You can add all sorts of other stuff into this data, your outage database, your trim cycles, your priority, your fire risks, how much volume, right? You can send the whole thing out to people that are going to potentially go out and cut against it. And for estimating, if you do it at a large scale, now what you never had before when you were running trucks or boots on the ground is a view of the whole system over time. What's been cut, what needs to be cut, how did it look if you do it multiple cycles, how can we change our program to best address potential power outages or fire risk? So all this stuff now is getting done from high density LiDAR. So it's neat stuff. This is the last 7-8 years that's really gotten big. Many years ago, I used to go out and try to convince utility companies to do this, and a lot of them didn't want to, but now they do. So quick on hazards. I got like 5 minutes left. Just gonna say this. I couldn't find the video I wanted. We do some stuff for CDOT in Colorado where we go and fly, rock walls and monitoring areas. But what I learned is you have no idea. It's probably true in Idaho. How many things are getting ready to fall on your head when you're driving around? It is crazy. And so there's these huge programs where people are out using LiDAR to monitor these big rocks and landslides and things. And used to have to go climb up and take a look-see, and now we're sending drones up and doing these high-density LiDAR point clouds and feeding into software that models how it might crack, fall, break, whatever. But so all sorts of applications. We do it a lot for pipeline companies because you don't want landslides into pipelines, as it turns out. So you're looking for erosion, deposition, potential fail areas. You get clients that come all the way over there on the right side and say, oh, geez, this looks a little unstable, and we'd like to get it flown and do some analysis. And then you see on the bottom, it was indeed unstable, and he had a big landslide, and that's the post landslide shot. Other just sort of things to think about. this is probably not a natural hazard, but you know, when you drive under bridges or you watch semis drive under bridges, loads and things, that's not accidental that they know where they're driving, right? That's all routed because it is a hazard. Think about, you know, fuel being transported, whatever. People are looking at this using LiDAR. They're going underneath all the bridges and they're doing all the measurements to make sure people aren't smashing into the tops of bridges. Airports, we were just talking with avians over here. You know, when you take off on your glide plane there off the runway, it's not a mistake that you're not running into a cell tower or a tree or, you know, some guy that decided to build this kid tree house that's too tall for the glide path. And a lot of that stuff now is getting done with LiDAR. We're going out and flying it and doing these sort of automated routines that say, hey, we know this is the glide path. Look for any obstruction that might fall into that area. And then that top one is just a weird one that I found in Kentucky. That's just a bunch of sinkholes that somebody was interested in figuring out what it is. All generated from LiDAR. So those are all treetops you see that might cause issues. All right. This is a sad one, but I'm just going to quick talk about it because this is LA. So we're all familiar with what just happened in LA. We happen to do a lot of work out in LA County. We're kind of part of that world and community. And we were out there. And so we went out and flew pretty high density LiDAR. And the team in Lexington, awesome people. They did overnight. They all stayed up all night, processed it, got it back to people that can use it, right? The Corps, first responders, the county, FEMA. Anyway, a powerful tool to sort of get some initial look at what happened. And because it's been flown before, of course, you have before and after data sets, but it can be a really powerful tool for those kind of response things. It happens with hurricanes and all sorts of other stuff too. But yeah, great tool. So digital twins is another one. It's like AI. You can't go anywhere anymore where somebody's not talking about digital twin or AI. It's moving, right, quick. And with my last few minutes, it means different things to different people, to me, us, whatever. You know, it's about sort of capturing reality of physical space, moving it into a virtual space, being able to test, being able to try things, being able to design things, and then taking what you've learned in sort of this digital twin virtual environment and pushing it back over into physical space. And it's like this loop of sort of capturing data, being able to utilize it, get back in. All sorts of different use cases, really powerful tool. We spent our time wisely by making virtual reality fly-throughs. This is high-density LiDAR. That guy is Josh Chappell. He got to do this. I didn't, but apparently it's really cool. So we flew really high-density LiDAR, and then they, I think, pushed it into a gaming engine, whatever. And then the second one, I was just telling Ashley, I was at a meeting. I didn't even know we did this stuff, but if you saw the last Godzilla movie, keep your eye on Rio de Janeiro here. That's LiDAR, right? We flew it at like 200 points of LiDAR, and then, I don't know, I think that probably went into a gaming engine, but they end up destroying it. So, but we're not wasting all of our time on cinematic glory. Push to an extreme. This is Hong Kong. Again, this is 100 points per meter, 200 points per meter. Super cool base for everything, right? Public safety, utilities, public event planning. All this stuff is great. It's beautiful. You go to, you go to a conference and you go to somebody's booth. This is probably what you're going to see. But the reality is, that's really expensive. That's LA. That's on Esri online, right? So it's starting to become accessible. I put this one in here because I think it's also interesting. We're doing some testing with them right now on the reality platform. That is a point cloud that is not LiDAR. It's generated structure from motion, only imagery. So photogrammetry math to generate a point cloud off of super overlapped images, create a 3D model. I point this out because from a cost perspective, it makes things more accessible. The reality of digital twins is not a lot of people are doing this kind of stuff. What they're doing is scaled versions of digital twins, right? So infrastructure, substations, factories, landscapes, transportation networks, data centers, indoor mapping. These are the tunnels underneath Houston, which nobody had a map of. There's like miles of them, and so they did it for a public safety reason. But I think the scale of digital twins and LiDAR as a foundational data set for those are starting at a smaller scale, right? So it's not mapping cities as much. So although some people are doing that, It's really looking at these smaller units where we can use the digital twin model, use LiDAR to capture reality, move it into some kind of model, and then that cycle starts, right, of maintaining data and updating data and modeling data at a smaller scale. Eventually, are we going to get to large scale all over the place? Absolutely. It's moving super quick. So, I'm 2 minutes over. But anyway, last thing, bunch of LiDAR tools. Right, I don't work for Esri, but a lot of people use Esri, so I mention it because there's some tools in there that you can do some of these things, right? Classification, running some of those raster things, modeling. Other tools, absolutely free, cheap, more accessible maybe to the, non-hyper user or whatever. But it makes things more accessible to more people. So you don't always have to come to some guy like me. You can just do some of this stuff on your own.